Let's have a look at a second example, and this brings about our general way that we set out the theoretical binomial distribution. So you might see it written as x is approximately equal to the binomial distribution where n is 10 and the probability of success p is 0.7. So that's what that means. And so you might get something like x is approximately equal to bi, or it could just be b, and then n comma p. You might be given that information, and n and comma p is all you need. Now in a moment I'm going to show you how to do this in a calculator, but first let's just do a couple of these questions. The probability that x equals 3 is going to be n, and n of course is 10, so 10c3 times by 0.7, which is p, to the power of 3 times by 0.3, which is q, to the power of 7, 7 being 10 minus 3. And we can put that into our calculator. So to find the NCR, we go into our options, and then we go to stat. My apologies. And to find the NCR, we go into the option menu, and then we go to probability, and NCR is just there, F3. But I don't want to use the answer, so I've got to make sure that I've got my first number. So I want 10, and then C, 3, times by 0.7 to the power of 3, and then times by 0.3 to the power of 7. And that gives me a really small number, 0.009. So this is equal to 0.009. And you know, that's what we expect, because the probability of success is 0.7, so the chance of me getting 3 out of 10 only is actually going to be quite small. And then I want to calculate B, the probability that x is less than or equal to 3 is going to be equal to the probability that x equals 3 plus the probability that x equals 2 plus the probability that x equals 1 plus the probability that x equals 0. And this is where we can use our calculator really effectively. So you may be expected to set this out in a tech-free exam for a really simple case, multiple probabilities, but mostly this will be in a tech-active exam and you'll be able to use your calculator. So we go to the calculator here. If we back out and we head back around to the first menu in options, we get stats, and in stats we get distributions, and then we can choose binomial. And I'm going to choose binomial CD, because binomial CD is a cumulative distribution. It gives me a range. I can go from 0 to 3, whereas binomial PD means I can only do for exactly 3 wins. And the inverse B, INVB, that is the inverse binomial distribution, which means we know the probability and we're trying to find something else out. Binomial CD, the notation is to put your range in first, starting with our upper bound, comma, lower bound, comma, N, comma, P, close brackets, execute, and you'll have to forgive me because I think actually it's meant to be the lower bound than the upper bound. So let's try this again, and we get 0.0106. So in P we get this is equal to 0.0106. And then we have, sorry, just trying to wipe something off my screen. Question C, the probability that x is greater than or equal to 3. Well, this is also equal to 1 minus the probability that x is less than 3. And we've almost got this here. So we could use this answer and do 1 minus the probability that x is less than or equal to 3, but then add back in the probability x equals 3. So it's 1 minus the answer to B plus the answer to A. But I do want to take this opportunity to show you how we can determine this using the stat menu as well. Because doing it in the calculator menu, as you just saw, relies on you knowing the syntax. So knowing that you have to put the lower bound first, the upper bound second, etc. If you go to the menu and go into statistics, in statistics, it means I can go in here, I've got some preloaded data, and I can click on F5 distribution, it's in your option menu, and I've already got binomial there. And I can choose BCD, and it allows me to go through here and set things, and I don't have to worry about syntax. Be careful, if you notice the discontinuity in my video, it's because I just came in here and I actually had that set as list, and things go a bit funny there, and you won't really need to do that. Make sure you've got that set as variable, and then I can put my lower as 1, my upper as 3, my number of trials is 10, and my probability of success as 0.7, and then it calculates that probability for me. No concerns about syntax. So if you have any issues, you can do that. So I'm going to go through here and do my lower is 3 and my upper is 10 and do that calculation, and 0.9984 is the answer. So this is 0.9984. I've got some of this information over here on how to do these calculations, so you can have a play around with that as well. Pause the video here if you want to write any of this down. Lastly, question D is calculating the probability that x is greater than or equal to 3 given, so I shouldn't have closed that bracket, that x is greater than or equal to 2. So this is saying that x, we already know x is not equal to 0 or 1. We want the probability that x is greater than or equal to 3 given this. So if I just move this question down a little bit, what this means for us is we can call on that conditional probability formula from our formula sheet, which is the probability that x is greater than or equal to 3 and x is greater than or equal to 2 over the probability that x is greater than or equal to 2. But in this case, if x is greater than or equal to 3, well, it's already greater than or equal to 2. So in some special cases, such as this binomial probability where we're looking at ranges, it's just x is greater than or equal to 3. And this is not, if x equals 2, this condition is not satisfied. So then we've got that over that, and I can do that calculation in my calculator quite quickly. So I just exit out of this. I'm going to go to menu. It's a bit easier to do it in the run matrix because I can go option, stat, distribution, binomial CD, and then I can do 3, 10, 10, 0.7. That's for x is greater than or equal to 3, and I can divide that by and do another BCD, 2, 10, 10, 0.7, and it will give me 0.99855. 0.9986 to round to 4 decimal places. And there's our answer to all the parts of example 2, and also a good opportunity for us to see this general form of a binomial where it's just the theoretical form, and also to play with the calculator.